Okay, for the final piece of the review, for the prerequisite review, problems 8, 9, and 10, I just want to put this thing to bed. I'm just going to try to do them all at once, and hopefully that won't take me too long, but you can fast forward if you need to find the specific question that you were struggling with. So off we go to the questions we're looking at. So again, for me, every time I see a non-linear inequality, which is all of these things, then what I like to do is I kind of pretend it's at equal. But my go-to is to look for the possible factors. And 2 is a prime number, so 2x squared must be 2x times x. The only product that's going to give me 21 is either 3 and 7 or 20 and 1 and 1. And I think most of you probably realize it's going to be 3 and 7. But specifically, it has to be in that order. And that's actually something that you should know. It's called the fundamental theorem of algebra, is that when you factor things, there's literally one and only one answer. It has to be a certain way. You can't get the same answer by having a slightly different factor set. 6 and 7 would make 1 if the 7 was positive and the other one is negative. Now, in this case, whether I called it equal and then transition back to an inequality or just leave it alone, it's fine. But clearly negative 7/2 and positive 3 are the numbers where 0 would happen. Because this says less than or equal to 0, I would like both of those to be true. And then we just have one step further. Now remember, this is an upward sloping parabola because the leading coefficient is positive. That means the problem should be positive on the right and left. It should be negative down in the middle. And this particular problem is asking me where is it below 0 or equal to 0. So that's going to be this region in here. So I could say that x is an element of the values from negative 7/2 to 3. And again, that's being a little more formal. And sometimes we can be a little bit less formal. Now, in the next question, I was kind of messing with you a little bit. Because when you go to factor that, you get x minus 6 times x minus 6 is greater than 0. Now, this is still a quadratic, but it turns out there's only one root at 6. In fact, both of those have the same root. And that's where 0 would happen. But this says I want greater than 0. And just like before, this is an upward sloping parabola, so I know that it's up on both sides. And so I want to know, where is this thing greater than 0? Well, the easiest way to say it is it's greater than 0 everywhere except at 6 itself. So all we do is to say, well, just don't pick 6. That's probably the easiest way to express that answer. Okay, now letter C is the first one where we get ourselves into a little bit of hot water, where we try to solve it and it just doesn't solve well. So we could do the completing the square, or we could do the quadratic formula. And this particular go around, I decided to do the quadratic since I haven't done that very many times. So remember, and by the way, it is not factorable. You try it, it just doesn't work. You start off with x equals the opposite of b. So remember, b is negative 3, so it's positive 3. Then we do b squared, which is 9. And I would really honestly encourage you to just do that in your head. Don't grab a calculator. And if we do negative 4 times 5 times 4, well, 4 times 5 is 20. 20 times 4 is 80. And as we do that, we actually get a negative times a positive times a negative, which is a positive 80, all over 2a, which is 10. So that means on my number line, I have 3 plus root 89 over 10. I have 3 minus root 89 over 10. Both of these are solid dots because we said we want those. And in this case, we wanted the numbers that are positive. Now, again, we've been discussing the fact that in a parabola, this is an upward sloping parabola, which should be up on the right and left, but down in the middle. And I want to know when this thing is positive. And that's going to be out here and out here. So I would say it's from negative infinity until 3 minus root 89 over 10, inclusive. And then union with that 3 minus, actually plus root 89 over 10 to infinity. Now that looks like a really ugly answer, but that's just kind of all we can do with that. Okay. So number 9, we went away from just straight quadratics into these two questions right here and this one as well. These are all cubic, so they're going to have a little extra wrinkle. Now, both of these are going to be solved by the look of common factors, okay? So this is a cubic, but it's really not a cubic in the traditional way. We're really going to have to work super hard because these both have an x in common. So if I do that, then I can see very rapidly that the zeros would happen at root 2, negative root 2. Those would be the two zeros of this part because root 2 squared minus 2 would be 0. And then if this part was 0, you'd have it as well. Now, again, this is, one of those things where we have broken the number line into 4 regions, left, right, and 2 in the middle. And so we're going to pick a number, like above root 2 might be something like 6. Well, 6 times 36 minus 2, is it positive? Well, of course it's positive. And that's actually something that I want. But if I tried a number like 1 times 1 minus 2, this product of 1 and negative 1 would be a negative. That is not what I want. So that would not be a valid answer. But if we tried in here at negative 1, let's say, because the square root of 2 is about 1.4, so we could go negative 1. So I'd have negative 1 times actually negative 1 is positive. So that's a positive. That's a yes. And if you kept going, that turns out to be a no. So our values would be that you could pick, again, I'm being a little bit more formal using this notation because sometimes I do and sometimes I don't. We don't always have to be formal, but we can be when we want to be. So it'd be everything from negative root 2 to 0, and then everything from root 2 to infinity. Now, I highlighted B for a very specified reason. This is a little strategy known as factoring by grouping. When I teach Algebra 2, this is a topic that I kind of like to emphasize because it is a very, very, very useful tool in a lot of mathematics. So if I stole an x plus 2 from each one of these pieces, I would still have my x squared, my minus 2x, and my minus 15. And that, now that I've taken that out, I'm left with a very simple factorable quadratic because 5 times 3 is 15. But I could get the negative 2 if I made this one negative and that positive. So you notice you got x squared, right? A negative 5x and a positive 3x makes negative 2, and there's negative 15. And so we can yet again make my little number line. 5 is the largest number that I have. Negative 2 is next largest, and negative 3 is the next largest. We can't have any one of those numbers because they would yield a bad answer. And of course, if I plug in anything above 5, like 6 or 7 or 10 or 100, every single piece is a positive. And the product of 3 positives is positive, and I don't want that. But if I try in here, like 4, I get a positive times a positive times a negative. And the product of 2 positives and a negative is negative, and that is exactly what I want. The same logic over here, if I try negative 2.5, I get a negative times a positive times a negative, and that's positive, and I don't want that either. But of course, any number below negative 3, like negative 8, that's going to be negative when I plug it in. Negative 8 plus 3 is also negative. Negative 8 minus 5 is also negative. All of these guys are negative. And the product of 3 negatives is definitely a negative. So my truth region are both of these. So that's going to be, again, I'm being less formal this time. It's everything from negative infinity to negative 3, and then everything from negative 2 to 5. Now, for part C, I kind of purposely hung that out there just a little bit because you might look at it and really start to think, what can I do? But there's no group that's explicitly given like I did in part B. There's no greatest factor that I gave you right here. So at this moment in time in our course, until we do some more sophisticated algebra, we pretty much are going to be stuck and just going to say, well, let's grab our calculator and ask the question, when is this graph underneath the x-axis? So that's what we're going to do. Somebody put a bunch of junk in this calculator. So let me get rid of all this stuff. Okay, so we're going to type in negative 2x to the third plus 12x squared minus x. and a -3. Now, I don't know what the right window is, but usually these problems are not very big. So I'm going to try -6 to 6. And I don't really know what to do for this one, but I'm going to go negative to +25 and just kind of see what happens. And I'm not loving the fact that this has that crazy screen thing on it. So I'm going to have to learn how to take this one off this calculator. But it's underneath the axis in this region right here, and then over here. So what I want to do is I'm going to find these values where it crosses from above the x-axis to below the x-axis, which is there. So I'm going to calculate the zeros. Really sorry that this thing has that weird stuff on it. So I'm going to go to the left of the root and hit enter. I'm going to go to the right of the root and hit enter twice. So at 0.445, and it remains underneath the axis from there until here. So I'm going to calculate the next one. That's going to be the next 0. Let's calculate that 0. So I'm going to move to the left of the 0, hit enter. Move over here to the right of the 0 and hit enter again. Trying to see if it'll go up. There it is. Okay, so it was until 0.574. And then there's a region where it goes from this number until infinity, and we're going to be done. Now, it's way over here to the side, so I'm not liking my window very much. So I'm going to open it up just a little bit. And I want to find out where is this place where it crosses from the x-axis and goes below. So second, calculate the 0 again. I'm going to move my cursor over pretty close to the number 6 is where we found it. Enter once above the x-axis, enter below once, and one extra enter, that's 5.87. And that's the region where this particular curve was sitting underneath the x-axis, because it's one place right here and one place right here. It's been a little while since I've tried to get a weird picture off my screen. I got to remember how to do that. Okay, and the last one, I'm supposed to make an inequality that has a solution of all of these numbers out here and all of these numbers right here. And quite simply, I would just write x plus 1 because that would be a simple factor that would yield that root. 2x minus 7 is a factor that would yield that root. And if I picture this as a simple parabola that is going up, I'd be looking for the region of that parabola that is above the x-axis. So I'd simply answer the question, when is it greater than 0? And ladies and gentlemen, that is the end of our journey on our prerequisite. So I will see you guys back in class. We're done. Bye-bye.